Welcome to Complexity Made Simple. My name is Paul Allen, and the subject of today's video, well, we are going to take a look at visualizing your problem so that you select the correct continuous improvement approach. That's what today's video is about. But before we do that, I just want to draw your attention to the latest book that I've just released. Statistical Process Control for small batch production. You can get this from lulu.com. The link is in the description below. If you're interested in slightly more technical problem solving tools like design of experiments, and if you want to be a world-class engineer, you should be brilliant at design of experiments. Design of experiments for 21st century engineers, also available from lulu.com. And finally, if you're a green belt or a black belt watching this and you've recently certified and you really want to get on with some projects and save bucket loads of cash, drink tea and read the paper. We'll tell you the practical way of applying all that good stuff that you've learned. And in fact, this video is about that very thing right now. We're going to talk about how to practically apply some of the stuff that you've learned in the right way. But the links to those 3 books are in the description below. Please go and buy 1, 2, or all 3 of them. Your support is always appreciated. Thank you. So let's talk about this. So what we want to do, visualize. I want you to visualize the problem. Why do I want you to visualize the problem? Well, if you do that, you can select the correct improvement technique. If you don't do that, you are effectively going to be consigned to the group of people who constantly try and improve processes, and the problem comes back again and again and again and again. I know that wouldn't be happening to you folks, but you wouldn't believe how many times engineers try to improve a problem, make a problem go away. 2 weeks later it's back. A month later it's back. Why is that happening? Because you're not doing this. Let me show you. Effectively, technical problems, dimensional problems in particular, performance problems, etc. They manifest themselves in 2 different ways. The problem could look like this. Here's your tolerance. Your process was working perfectly fine. Everything was good, relatively defect free or low defects. And then all of a sudden, bang, it does that. This is what I would call a shift in the mean. The mean was sitting dead in the middle there, and now the mean has moved up there. So if you were looking at it on a graph, would look like that. But there is another type of problem, and it's the problem that's more common, and it's this. You've got your tolerances. Your process is doing that. Now this process doesn't have a problem with the mean. The mean, the middle, is sitting dead on target. What you have a problem with is the variability. You have a problem with the noise. So another way of looking at this is a problem with the signal when the mean shifts. This is a problem with the noise when it is spread related. 90% of problems in most of my clients look like this. Now that's what you're going to see if you plot a graph. There's an alternative way of looking at it, and it's to look this way at the graph, and what you're basically seeing is this. Look, process used to look like that. Now the process looks like that. We're producing defects. It's a mean shift. This one on the other hand would look like this. The mean ain't shifted. It's dead on target. Think about what you have to do here. Here something's changed. What you're going to do is you're going to grab a dial and you're going to put it back on target. Somebody is violating the rules here. So it could be that the machine has got a bit of a problem on it and it's flicked off the target, but it could also be someone's chosen a new setting. Someone's untrained, a technician's gone in and upset the calibration of something. This a sort of a single root cause. This thing will have one, root cause. Usually it'll take 3 minutes or maybe 3 days to fix. Usually one person can fix it. You might choose to use the 5 whys, yeah? So select the correct improvement technique. So you might choose, okay, technician went in, disturbed the calibration of the temperature controlling system. That put us off target, even though we thought we were set correctly. Then you can go, okay, 5 whys. Why did that happen? Why did that happen? Why did that happen? 5 whys, very quick. You can complete your 8D investigation in about 3 days, and you can put it on someone's desk and be ready to come up with a solution. No problem. But what I tend to find is 90% of technical problems are like this. They are about too much noise. Now think about it. If I grab a dial here, I can put that on target. If I grab a dial here, what will I do? Well, I just move this thing backwards and forwards. The solution here is totally different to the solution here. And if you try to use the solution here, what will you do? You'll make it worse. Why do you keep getting your problems coming back again and again? Because you get this problem. You step in and take some action. The problem seems to go away for a while. Then you get this problem. You step in and take some action. Problem seems to go away for a while. Then it comes back again. You're not having any effect at all here. In fact, the only effect you're probably having is moving this thing backwards and forwards. Now this is multi-causal. This is multi-causal. This will take you 3 months to get this fixed. You will need a team. You will probably need a project. There will be all sorts of things. The quality of the raw material that you're buying, the standard of the maintenance routines, the fact that you might be running to breakdown and not doing any breakdown routines. This is like rolling 10 dice. When you roll 10 dice, sometimes you roll 60 and sometimes you roll 10. But when you get 60, what's the root cause? Well, there isn't one. All the dice, multi-causal, all the dice had to be high. To get close to 60, all the dice have to go high at the same time. When you get low numbers, what's the root cause? All the dice have to go low all at the same time. But most of the time when you roll the dice, what happens? You get numbers in the middle. Sound familiar? That's what you need to do. You need to visualize your problem. Is it signal or is it noise? This is going to take you 3 months to fix. Needs a cause and effect. Needs a cause and effect diagram. Probably needs a control plan. This one up here, it has a control plan, but one of the controls has slipped out of control, and it's done that. And the investigation is very short. You can finish your 8D here, 3 days. Here, you can finish your 8D in 3 months. Most problems I see are like this. If you don't select the right, if you don't know what's wrong, you won't select the right approach, you won't get anywhere. You'll keep getting your problems come back again and again and again. I know that wouldn't happen to you, but some companies it does. Now, here's a flow diagram, look, of this very approach. It tells you, are we in chaos? This is what I would call chaos. Were we in chaos? Or were we in control? Because depending on whether you were in chaos or control, depends on which problem solving technique you use. Here's the flow diagram that shows you how to do this. It tells you which tools to use and maybe how long you're going to take using these tools. If anybody wants this flow diagram, drop me your email in the comments below and I'll happily send you the flow diagram. If anybody wants to know how to remove noise from their process and make pots and pots of cash, drop me your email and we'll discuss how I can help you. But if you don't know the difference between chaos and control, signal and noise, you have to visualize this. You have to decide which problem you've got, then you'll take the right approach, then you'll get rid of your problems forever, then you'll make pots of cash and please your customers like you wouldn't believe. The difference between chaos and control is the difference between success and failure in your continuous improvement and problem solving processes.